Hey everybody, in this video we're going to talk about solving a 2x2 system of linear equations that is inconsistent or consistent dependent. Now remember, if a system is inconsistent, what does that mean? Okay, if it is consistent dependent, what does that mean? If it's inconsistent, that means there's not going to be a solution. If it's consistent dependent, that means that there is going to be a solution, but that they're going to end up being the same line, so there are infinitely many solutions. So how are we going to solve this set of equations right here? Well, first of all, I see that it's in decimal form, so if I were to multiply both sides of each equation by 10, I would get rid of those decimals. So I end up with a new set of equations, which is 12x plus 4y equals 50, and 5x plus 5x, equals, I wrote down 5x, it would be 5y. Alright, let's give this another try. 5y equals negative 15x plus 2. But I can't really line my x's and y's up because this second equation is not in ax plus by equals c form. So if I add 15x to both sides on that equation, I will get 15x plus 5y equals, and it should be 20 because I multiplied the 10 by the 2 to get 20. Okay, now I can't do anything to cancel out any x's and y's here, but I do see that if I multiply this equation by 5, I'll get 20y. And if I multiply this equation by negative 4, I'll get negative 20y. So after I distribute this 5 and this 4 in, I'll get the first equation is 60x plus 20y equals 250. And then I also get negative 60x here. And then I get minus 20y equals negative 80. After I add these, I'm going to get a 0 here and a 0 here. So I end up getting 0 equals 170. That is not a true statement. So this is false, which means nothing is going to make it so these two lines end up crossing at any point. So I have no solution for this one. Okay, let's go ahead and do another one. So for this problem, I'm told to choose the best description of the solution of this set of lines, or this system of equations. But for here, I'm already given one where y is solved. So if y is solved, I can just plug that y into the y of my other equation. So I would get 6x plus 2y, but I'm told in my second equation y has to equal negative 3x plus 7, which has to equal 14. So that's plugged into this first equation. So I'm going to get 6x, distribute the 2 in, and I get minus 6x plus 14. And that's equal to 14. 6x minus 6x is 0. So I end up getting 14 equals 14. Is that true or is that false? That's a true statement. So I don't get x equals something. I just end up getting a true statement with all of my variables canceled. So because I have a true statement, this means these two equations are the same line. And they have infinitely many solutions because they end up lying on top of each other. So what is the equation that will satisfy? Well, for this case, we have y equals negative 3x plus 7. And what does that mean? Well, that is the line, right? So I go up 7 and I have a slope of negative 3. So any point that has an output that follows y equals negative 3x plus 7 will be a solution to my equation. So for this, how do we do these? We can solve either equation for y. In this case, y was already solved for, but if it's not, then all we have to do is for either equation solve for y, and we get our answer. Yeah. So that is solving 2 by 2 systems of linear equations that are inconsistent or consistent dependent.